Tonight, we are going to talk about a superpower. It isn't magic. It isn't science fiction. It is a capability we have possessed for over 400 years, yet most of us never truly understand what it means. When you point a telescope at the sky, you think you are looking at places. You think you are seeing stars, planets, and galaxies as they hang in the void. But you aren't. You are not seeing the universe as it is. You are seeing the universe as it was. The telescope is not just a magnifier. It is a time machine. Every photon hitting its mirror is a messenger from the past. Every image we capture is a historical document. And the deeper we look, the further we travel back toward the moment of creation itself. By the end of this journey, you will understand why the present moment does not exist in the cosmos. You will see how we resurrected the universe's history from light. And you will face the ultimate wall, the point in time beyond which no telescope can ever see. For thousands of years, we believed light was instant. If a lightning bolt struck, you saw it the moment it happened. But in 1676, a Danish astronomer named Ole Rømer noticed something unsettling. He was watching the moons of Jupiter. He noticed that when Earth was far away from Jupiter, the moons would disappear behind the planet later than predicted. When Earth was closer, the eclipses happened earlier. The moons weren't changing their speed. The information was simply arriving late. Rømer realized the universe has a speed limit. Light takes time to travel. It moves at 186,000 miles per second. In our daily lives, that feels like instant. But space is so terrifyingly vast that even light looks like a snail crawling across the void. This delay creates a ghost in the machine. Look at the moon. You aren't seeing it now. You see it 1.3 seconds ago. Look at the sun. That is 8 minutes of history. If the sun vanished right now, we wouldn't know. We wouldn't feel the cold or see the dark for 8 whole minutes. We would be orbiting a ghost. Go further. Look at Jupiter through a backyard telescope. That light left the giant planet 40 minutes ago. You are watching a past version of Jupiter. Aim at Sirius, the brightest star in our winter sky. That light has been traveling for 8.6 years. Think about that. When the light hitting your eye tonight left Sirius, the smartphone in your pocket hadn't been invented yet. And that is just our neighborhood. Look at the Andromeda Galaxy. It is the furthest object you can see with your naked eye. The photons striking your retina tonight began their journey 2.5 million years ago. They left Andromeda when Homo sapiens did not exist. They traveled across the intergalactic void while we discovered fire, built empires, waged wars, and flew to the moon. Only now, tonight, do they end their journey. Distance is time. The telescope turns the sky into an archaeological dig. The farther out you look, the deeper down you dig into the strata of history. This leads to a haunting realization. The night sky is a lie. Or at least, it is an illusion. Take Betelgeuse. It is a dying red supergiant, swelling and pulsating, destined to explode as a supernova. We know it will die soon. But soon in cosmic time means maybe tomorrow, or maybe in 100,000 years. But here is the catch. It might have already exploded. If Betelgeuse died while Leonardo da Vinci was painting the Mona Lisa, the light of its death would still be traveling toward us. We would look up tonight and see a living star, blissfully unaware that it is already a corpse. There is no now in the universe. Now is a local bubble. Everything else is a postcard from a time that is already gone. Sometimes, we catch the ghosts in the act. In the year 1054, astronomers in China and the Middle East saw a guest star appear in the sky. It was so bright it was visible during the day. They were witnessing the death of a massive star 6,500 light-years away. But the explosion didn't happen in 1054. It happened in the Stone Age, roughly 5,500 BC. The light just finally arrived. Today, we point our telescopes at that spot and see the Crab Nebula, the expanding wreckage of that explosion. We are studying the forensic evidence of a disaster that happened before the first pyramid was built. At its center lies a pulsar, the crushed heart of the dead star, spinning 30 times a second. By tracking its spin, we can calculate exactly when it died. The math matches the history. The telescope allows us to be cosmic coroners, performing autopsies on stars that died long before we were born. They traveled across the intergalactic void while we discovered fire, built empires, waged wars, and flew to the moon. Only now, tonight, do they end their journey. Distance is time. The telescope turns the sky into an archaeological dig. The farther out you look, the deeper down you dig into the strata of history. So, if looking far away means looking back in time, what happens if we look everywhere? Can we see the universe growing up? Yes. We call it cosmic archaeology. In 1995, we pointed the Hubble Space Telescope at a tiny patch of nothingness, a space no bigger than a grain of sand held at arm's length. We left the shutter open for days. We didn't see nothing. We saw everything. Thousands of galaxies. But look closer. These aren't the majestic spirals we see nearby. These faint red smudges are billions of light-years away. We are seeing them as they were 10 billion years ago. And they look different. They are small. They are messy. They are chaotic. Just as an archaeologist digs down to find primitive tools, astronomers look back to find primitive galaxies. We see them crashing into each other. We see them merging. We see a universe that is violent and unfinished. We call this era cosmic noon, the peak of star formation, about 10 billion years ago. Back then, the universe was a factory on overdrive. Stars were being born 10 times faster than they are today. Black holes were feeding voraciously, lighting up as quasars that outshined entire galaxies. We don't have to guess how the Milky Way formed. We can watch it happening to other galaxies, billions of years in the past. We are watching the assembly of the modern universe, frame by frame. They traveled across the intergalactic void while we discovered fire, built empires, waged wars, and flew to the moon. Only now, tonight, do they end their journey. Distance is time. The telescope turns the sky into an archaeological dig. The farther out you look, the deeper down you dig into the strata of history. But we wanted to go deeper. We wanted to see the first stars, the ones that lit up the darkness. But there was a problem. The expansion of the universe stretches light. The ultraviolet glow of the first stars has been stretched over 13 billion years into invisible infrared light. Hubble couldn't see it. So we built a new time machine. The James Webb Space Telescope, a giant gold eye designed specifically to see the invisible heat of the early universe. And what it found shocked us. We expected the first galaxies to be tiny, weak blobs. Instead, Webb found monsters. Galaxies from only 300 million years after the Big Bang that were surprisingly massive, mature, full of stars. It was like digging into an ancient ruin expecting to find stone huts, and finding a skyscraper instead. Webb is taking us back to the epoch of reionization, the cosmic dawn. The moment when the first stars turned on and burned away the hydrogen fog that filled the early universe. We are hunting for population 3 stars, the mythical first generation. Stars made of pure hydrogen and helium, massive and short-lived. We haven't snapped their picture yet, but we are closing in. We are looking at a time when the universe was less than 5% of its current age. They traveled across the intergalactic void while we discovered fire, built empires, waged wars, and flew to the moon. Only now, tonight, do they end their journey. Distance is time. The telescope turns the sky into an archaeological dig. The farther out you look, the deeper down you dig into the strata of history. We have looked back millions of years. We have looked back billions of years. But eventually, no matter how powerful the telescope, we hit a wall. There is a horizon in time beyond which optical light simply cannot pass. Travel back to 380,000 years after the Big Bang. The universe wasn't black space yet. It was a hot, dense fog of plasma. It was opaque. Atoms hadn't formed yet. Electrons roamed freely, scattering every particle of light that tried to move. The universe was a glowing cage. Then, the universe cooled. The temperature dropped below 3,000 degrees. Electrons bonded with nuclei. Atoms formed. Suddenly, the fog lifted. The universe became transparent. And for the first time in history, light was free to fly. That first flash of light is still flying through the universe today. It is everywhere. It is touching your skin right now. In 1964, 2 radio astronomers, Arno Penzias and Robert Wilson, built a sensitive antenna. No matter where they pointed it, they heard a persistent hiss. They thought it was pigeon droppings on the antenna. They cleaned it. The hiss remained. They had accidentally discovered the cosmic microwave background, CMB. This isn't just static. It is the afterglow of the Big Bang itself. It has been stretched by the expansion of the universe, from blinding white light into cold microwaves. This is the baby picture of the universe. A snapshot taken when the cosmos was just an infant. Optical telescopes cannot see past this wall. Before this moment, the universe is dark to our eyes. They traveled across the intergalactic void while we discovered fire, built empires, waged wars, and flew to the moon. Only now, tonight, do they end their journey. Distance is time. The telescope turns the sky into an archaeological dig. The farther out you look, the deeper down you dig into the strata of history. This time delay doesn't just apply to dead stars or ancient radiation. It applies to life. Since 1995, we have discovered thousands of exoplanets. Some are in the habitable zone. Let's say we point a future telescope, like the Habitable Worlds Observatory, at a planet 100 light-years away. We analyze its atmosphere. We find oxygen. We find methane, the signatures of a breathing, living biosphere. We celebrate. We have found aliens, but have we? We aren't seeing them now. We are seeing them 100 years ago. If we send a radio message to say hello, it will take 100 years to get there. If they reply immediately, it takes 100 years to come back. By the time we hear their answer, 2 centuries will have passed. The civilization that sent the reply might not even exist anymore. Conversation is impossible. We are just reading their history books. Now, flip the mirror. Imagine there is an advanced civilization in the Andromeda Galaxy, 2.5 million light-years away. They have a telescope powerful enough to zoom in on Earth's surface. They look at us right now. What do they see? They don't see the Great Wall of China. They don't see bright cities at night. They don't see humans. They see our ancestors. They see a planet of primitive hominids. Or perhaps, depending on the distance, they see dinosaurs roaming a green world. The light from our modern civilization hasn't reached them yet. To the rest of the universe, we haven't happened yet. We are trapped in a bubble of causality, isolated by the vastness of the void. They traveled across the intergalactic void while we discovered fire, built empires, waged wars, and flew to the moon. Only now, tonight, do they end their journey. Distance is time. The telescope turns the sky into an archaeological dig. The farther out you look, the deeper down you dig into the strata of history. For 4 centuries, we were limited by light. But what if we could hear the history of the universe? On the 14th of September 2015, we did. LIGO turned on. It didn't look for light. It looked for ripples in the fabric of space-time itself. Gravitational waves. 2 black holes collided 1.3 billion years ago. The crash was so powerful it shook the universe like a bell. That ripple traveled for 1.3 billion years, passing through galaxies and voids, until it slightly wobbled a laser beam in Louisiana and Washington. This is the future. Missions like LISA will launch detectors into space, spanning millions of kilometers. They will detect the mergers of supermassive black holes from the dawn of time. And perhaps they will hear the primordial gravitational waves, ripples from the very first fraction of a second of the Big Bang. Where light hits a wall, gravity passes through. We are about to listen to the moment of creation itself. They don't see bright cities at night. They don't see humans. They see our ancestors. They see a planet of primitive hominids. Or perhaps, depending on the distance, they see dinosaurs roaming a green world. The light from our modern civilization hasn't reached them yet. To the rest of the universe, we haven't happened yet. We are trapped in a bubble of causality, isolated by the vastness of the void. They traveled across the intergalactic void while we discovered fire, built empires, waged wars, and flew to the moon. Only now, tonight, do they end their journey. Distance is time. The telescope turns the sky into an archaeological dig. The farther out you look, the deeper down you dig into the strata of history. We are not done building time machines. In the deserts of Chile, the extremely large telescope is rising. Its mirror is 39 meters wide. It will gather 15 times more light than any optical telescope existing today. It won't just see distant galaxies. It will take direct pictures of planets orbiting other stars. In space, The Nancy Grace Roman telescope will scan the sky with a field of view 100 times larger than Hubble. It will create a 3D map of the universe's history, showing us exactly how dark energy has stretched the cosmos over billions of years. And the Square Kilometre Array will map the hydrogen gas from before the first stars were born. We are building a complete timeline, from the first second to the first star, to the first galaxy, to us. They don't see bright cities at night. They don't see humans. They see our ancestors. They see a planet of primitive hominids, or perhaps, depending on the distance, they see dinosaurs roaming a green world. The light from our modern civilization hasn't reached them yet. To the rest of the universe, we haven't happened yet. We are trapped in a bubble of causality, isolated by the vastness of the void. They traveled across the intergalactic void while we discovered fire, built empires, waged wars, and flew to the moon. Only now, tonight, do they end their journey. Distance is time. The telescope turns the sky into an archaeological dig. The farther out you look, the deeper down you dig into the strata of history. The telescope does not transport you through time physically, but it does something more important. It gives us perspective. It transforms astronomy from a guessing game into a history lesson. It tells us that we are part of a lineage. The atoms in your hand were forged in the hearts of stars that died billions of years ago. We are made of stardust. And through the telescope, the stardust has evolved eyes to look back at its own origin. The past is not gone. It is out there, racing toward us at the speed of light. All you have to do is look up. And the Square Kilometre Array will map the hydrogen gas from before the first stars were born. We are building a complete timeline, from the first second to the first star, to the first galaxy, to us. They don't see bright cities at night. They don't see humans. They see our ancestors. They see a planet of primitive hominids, or perhaps, depending on the distance, they see dinosaurs roaming a green world. The light from our modern civilization hasn't reached them yet. To the rest of the universe, we haven't happened yet. We are trapped in a bubble of causality, isolated by the vastness of the void. They traveled across the intergalactic void while we discovered fire, built empires, waged wars, and flew to the moon. Only now, tonight, do they end their journey. Distance is time. The telescope turns the sky into an archaeological dig. The farther out you look, the deeper down you dig into the strata of history.